and I'm here today to talk to you about our new mocking framework in Jade 2022. First up, let's have a look at how to get started with it. The Jade mocking framework is available on our public GitHub. It's not part of Root Schema. Now, once you've downloaded it, it's actually just a package that you can load directly into your schema. And you'll also want to make sure that you've turned on the feature with method mocking enabled equals true in your ini file. Now, let's see what we can do with it. First up, method stubs. You can use a mock method to stub out a method. It will then do nothing when called. It's essentially going, hey, let's not, and say we did. Next up, faking objects. Instead of feeding an existing object into the mocking framework, we can use the instantiate mocked object method to create an object using the mocking framework. When we do this, it won't call any create method or any constructor on that, which can be really useful if you've got some dependencies that you don't have. Finally, querying the mock. There are heaps of methods that we can use to pull out useful information after we've done some mocking. For example, getCallCount tells us how many times a particular method mock was called, and was received by tells us whether that method mock was received by a particular object. Thanks for watching. If you'd like to know more about the mocking framework, I'll be joined by Nick Scott for a demo session where we'll dive deeper. Hi, and welcome to our demo session for the Jade mocking framework. I'm Tim, and I'm joined here today by Nick.
Hi, thanks for joining us. I'm Nick Scott. I'm a senior developer at the plant here at Jade. And so we're going to talk about the mocking framework. I've got a demo lined up.
Nice, cheers. Let's dive right into the demo.
Okay, now Tim mentioned that it's a package that you download from GitHub. I've loaded it and stored it into my Jade environment here. We get a bunch of classes, and I'm going to show you how to use some of those classes in a brief demo. So here's my method, which I want to call this method, and I want to mock out the behavior. As you can see, we've got a message box here, which when we're running in our tests, we don't want a message box to pop up.
Makes sense, yeah.
Yep. So I'll full screen it for you to get a bit of view. So here's my call to the method, which is going to put up the message box. And we start by creating a mock manager. The mock manager is going to look after all of the class and method mocks that we create. We set up a class mock. In this case, the class that we want to mock is application, because we don't want the message box to be displayed. The method is the message box method on application, and so we create a mock for that method. Now, next thing we want to do, and you mentioned that there's a factory method to create an instance. In this case, we want to inject the app instance into the class mock so that the method mock will take effect for this instance. And then we do something. So let's see what happens when we run that method. As you can see, no message box.
Now I see that we got a result back that made it do it. What result are we getting back when we've mocked out this message box?
Okay, so by default, the mock, as you mentioned, it's a stub and it does nothing. So it's returned the null value for the type, which in this case is going to be the integer 0, which is going to be yes. And so the message box has behaved as though you had clicked yes. Now we can change that we can say that we want to return no from the message box. So now when we run the method, see what's happened? We've gone into the no path, and we've said don't do it. Now we can also, we've got other things that we can do. We can change what happens. We can inject some source into the method as well. So now what we're doing is I'm going to get it to output this code snippet. In this case, it's going to write out foobar. So you can see we've still set the return value for no, so we don't do it. Now what we can also do is we can access the parameters to the message, so we can actually output the message parameter to the message box method. So that's the string should I do something, which we'd pass into the message box. So you can see we've got all sorts of ways that we can. If you look on the mock method class, there are a number of methods where you can start changing the behavior and effectively faking the results that you want. You can change the return value, you can change parameters, you've got usage IO parameters, you can update properties, all sorts of cool stuff.
So that'd be really useful for things like message boxes, which obviously you don't want to have popping up in a test.
Correct.
Or maybe a web service if you're going to the internet. It's like, well, I don't want to go to the internet.
Yep, web things would, being able to fake out a web service would be great.
I mentioned that because I've actually used the mocking framework to do exactly that. It's been great.
Now, as well as stubbing out behavior and faking behavior, we can also query the mock to make sure that it's done the right thing. So there are a number of query methods. We can, and give you an example here, we can say, was the method mock actually called? And we can say, was it called on the instance of app? And we can also say, was it called with the specified parameters? So when we run that, you can see the 3 true results are saying, well, yes, this method was received, and it was received by the app instance, and it was received with the parameters that we've specified. Now, the method mock that's provided by the framework lives in the package, and we can easily debug into the method. So if I bring up the debugger, we now see that we start stepping through. Let's look what happens when we go in to the method. Now, we're about to call the message box, and this is with the app instance, and this is the method that we've mocked out. So if I step into it, I don't go into the mock method. Sorry, I don't go into the message box method, I go into the mock method. And so here we are, we can see if we look back on the call stack, there we are, we were sitting on the code that's calling the message box. And now we've come into the method mock, which lives in the package. And there's a bunch of parameters on here on this, which this method is going to capture the state. So it's going to capture the parameters that have been passed in, and then it's going to fake out any behavior that you've specified. It's going to update properties that you've said to update parameters, and and we've injected some code, so we'll execute the snippets. So you can see as we go through, we capture the call history, we mock the parameters, mock the properties, and we check the receiver, we're looking for code to execute. And so now, just before we exit the method, let's have a look at what's happened to some of these parameters. There's a call history's parameter, and we save away every time the method's called, the call history gets updated, and all the parameters to the method and the receiver are stored in the call history.
Oh, nice. So we've actually got every bit of information about what's happened.
We've effectively recorded the whole thing, yep. So when the query methods, if you've used the query methods after you've called the mock, it can go in and looks at this information that's in the parameters or the properties that you've got to say, well, yes, we called it, the parameters were this, the receiver was that, and so on. Now, there's a really cool thing here. I'd just like to do a shout out for the, if you notice that the parameters array, the values in there, we've got 2 strings and an integer. The framework makes a lot of use of a really neat feature that was in Service Pack 1, which was the array of any. Because this code is completely generic, it doesn't know the types. So it just puts everything into an any array, and it uses the any data type for passing things back.
So those could even be objects?
Correct, they can be objects, they themselves could be another collection or whatever. It's all of the values are captured and stored away. And the similar technique is used for updating properties and parameters and so on. So now we come back out. So that's pretty much the gist of what it can do. As I say, it's open source, so you can debug it yourself and see what's happening. And you can extend it.
I also noticed a couple of cool things in here. We've got up here on line 17, we're doing a mock method and then dot returns and then dot when called does, that kind of fluent style. So can you explain how that works?
Yes, sure. So the return value of the method is the method instance. So we could, an alternate way of coding that is to repeat the method mock, but it's more natural, and other languages support having a more fluent style, and so we've adopted that here, and it's quite nice if you've only got, in this case we've only got a couple of options, so it just keeps it nice and concise. You don't end up with screeds and screeds of repetitive code.
And the other thing I saw was we're creating all sorts of transient objects here, when we do create class mocks and things like that. And I noticed we don't need to clean them up at the end. The only thing that we're deleting is the mock manager itself.
Yep, the mock manager keeps track of everything. So you set up the mock manager. If you were writing it, say you were using it in the unit test framework, you'd probably create the mock manager in the before all method for the unit test, and then create the class mocks as you need. Now, the mock manager knows that you're creating the class mocks, and the class mocks create the methods, and you inject. If you use the factory method to create instances to mock, then the class mock knows about them. So when you're finished, when you delete the mock manager, it goes parent-child relationships. It goes and deletes all of the transient objects that have been created. Now you can delete them one at a time as you're going through. If maybe you might have a test, then you finish to create a class mock or a method mock, and then you just delete it in the epilogue of the test. That's fine. The mock manager has got less work to do when it closes it.
And that would kind of play into that fluent idea as well, because you're not necessarily assigning these to variables, which would make them harder to clean up. Like if I go, create class mock dot mock method, I can do that, right?
Sure. Yep.
Dot.
Yep.
And do all of my stuff, and maybe I didn't even, in this example you have, but maybe I wouldn't assign them to variables, but I might like to do that because my mock manager will clean everything up.
The mock manager will clean it all up. Yep.
Nice.
That's correct.
Cool.
Yeah, well, that's probably,
that sounds pretty good to me.
Yep.
Thanks for showing me that. And until next time, thank you for watching.